When we use a dynamic data type as a variable, we need to declare its data location, storage, memory, and call data. Storage means that the variable is a state variable. Memory means that the data is loaded onto memory. Call data is like memory, except it can only be used for function inputs. Let's take a look at examples of each of these. For this example, I'll be using a struct called myStruct, and with the mapping from address to myStruct. We'll be getting data from this myStruct, so I've already inserted one myStruct into the mapping. Now you've already seen that to modify a struct, the first thing that you can do is to declare myStruct followed by storage and then declaring the variable name. Here I am getting the myStruct struct from the mapping myStructs that is stored at message.sender. And I'm telling Solidity that the variable that I am about to use should point back to the storage, meaning the state variable. You would declare a struct as storage when you want to modify the struct. So for example, we'll modify myStruct.text by typing myStruct.text is equal to foo. When we execute this function examples, it will update the myStruct.text to foo. Now if you just wanted to read myStruct, we don't need to update it, we just want to get some data out of it, then instead you can replace this with memory. We'll copy this line of code and then change the keyword storage to memory, and then I'll also change the variable name to say read only. This will load myStruct stored at message.sender to memory, and you can also modify this variable. So for example, say read only.foo is equal to 123. Actually, I'll change this to 456. So we can modify this struct, but since the data is loaded onto memory, once the function is done executing, this change will not be saved. So use storage to update data and use memory to read the data. Now when you're writing a function both for input and outputs, you'll see the keyword memory and call data being used. So for example, we can pass in a uint array as input by typing uint brackets. So this is an array of uints. And then we need to declare the data location. We'll start off by saying that this data location is memory, and I'll call this input y. Let's take a look at another example. For the input, we can pass in a string, and again, I'll declare this data location as memory, and then I'll name this input s. Likewise, we can also return a dynamic data type, and in that case, we'll need to declare the return type as memory. If we wanted to return this array, then we would say return parentheses myStruct, and the data location is memory. And over here, we'll say return read only. Another example, let's say that I wanted to return a uint array. Then over here, I would type uint bracket and then type memory. I'll remove this return statement, and then we'll need to return a uint array. We can return this array from input, but just to make this example a little bit more interesting, we'll initialize a uint array in memory and then return it. We'll initialize an array of uint in memory by typing uint brackets memory. We're declaring that this array will be loaded onto memory, and I'll name this array memr, short for array in memory, equals to new uint brackets parentheses. For arrays that are initialized in memory, we can only create a fixed size array. We cannot create a dynamic array. So I'll declare this fixed sized array as having the size 3. Once the array is initialized in memory, this array has 3 elements since it is a fixed size of 3. So for example, let's update the first element by typing memr of 0 is equal to 2, 3, 4. And lastly, we'll return this array in memory by typing return memr. I made a mistake over here, so I'll change this return to returns. So this is how you initialize an array in memory. The syntax is a little bit tricky, but you'll get used to it. For the last example, let me explain what call data is. Call data is like memory, except that you can use for function inputs. And why would you want to use for function inputs? Well, it has a potential to save gas. Let's take a look. So we'll replace the inputs memory and memory over here to call data. Call data and also for the string Calldata. Now, since data type declared as Calldata is non-modifiable, meaning that we cannot change the values inside it, it can save gas when you pass this input into another function. For example, I've declared another function called internal, and it takes in the uint array from the input over here. Take the input y, and then pass it into the function internal. Now, if this input was declared as memory, then what Solidity would do is take this input, and when it passes on to this function, then it's going to copy each element in this uint array. So it will be creating a new uint array inside the memory, and then pass it on to here. However, if we declare this input as Calldata, then there is less one copying to do. It takes the y from the input and passes it into the internal function without copying it. So that is how it saves gas. In summary, use storage to load dynamic data that you will update. If you only need to read the data or modify it without saving it onto the blockchain, then you can use memory. And then for function inputs, use Calldata to save gas. Whenever this input is passed to another function, it saves gas by avoiding copies.